Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, we are going to learn about the Citral. So I will discuss about the definition of Citral, physical properties of Citral, isoprene unit of Citral, occurrence of Citral, isolation of Citral, industrial synthesis of Citral, reactions of Citral, and structure elucidation of Citral. And we will discuss about the uses of Citral. So what is the definition of Citral? You know Citral is a terpenoids and 3,7-dimethyl-2,6-octadienyl or lemonal is either a pair or a mixture of terpenoid with the molecular formula C10H16O. The two compounds are double bond isomers. E isomers is known as geraniol or Citral A. Z isomers is known as neryl or Citral B. Due to cis-trans isomers add carbon double bond nearly the aldehyde group obtained from essential oil of plant sources. You can see two isomers. The isomer geraniol has a strong lemon odor. The isomer neryl has lemon odor is less strong and sweeter. So physical properties of Citral. Citral is a clear yellow colored liquid with lemon-like odor, less dense than water and insoluble in water. Melting point of Citral is less than 10 degrees Celsius, minus 10 degrees Celsius. Density of Citral is 0.9. Citral is not stable to alkanes and a strong acid. When heated to decompositions, it accretes smoke and irritating fumes. So, isoprene unit of Citral. You can see Citral is a alpha-beta unsaturated aldehyde classified as a monoterpenoid compound from the 3,6-dimethyl octane series, characterized by a head-to-tail linkage of the two isoprene subunits. You can see the head and tail, head and tail. So, occurrence of Citral. Citral is present in the oils of several plants including lemon myrtles, cultivated in Australia for flavoring and essential oil. It is highest natural source of Citral. Citral as an isolate in steam distilled lemon myrtles oil is typically 90 to 98% contains Citral. Lemongrass, it is cultivated in India, Southeast Asia and Africa. Lemongrass is good source of lemongrass oil, which is good source of natural Citral. So lemongrass oil contains 85 to 65% Citral. Now lemon seed tree, lemon balm. Now friends, isolation of Citral. Citral is isolated from lemongrass oil, which is obtained from lemongrass by steam distillations. Lemongrass chopped or unchopped is filled in a distillation flask and fitted tightly so that the vapors and oils was not leaked out. Now the steam is injected into it so that the upcoming steam carries away the essential oil from the plant material. Then the lemongrass oil as well as the vapors are passed through the condenser where they condense as the oil is lighter than water, so it will float through the surface of water and it is easily separated. Now thus obtained is the lemongrass oil, which contains 85% Citral. You can see the setup. Industrial synthesis of Citral. First part, Claisen rearrangement involved and oxygen is a chair form transition state. Second part, Cope rearrangement. Only carbon is involved in a chair like transition state, and these two reactions happen in successive when the two starting material are heated together, and the reaction is driven by formation of conjugated carbonyl groups in products. So you can see 3,3 sigma tropic and forming the Citral. Now reaction of citral. Reductions of citral. Citral is reduced to either citranilin or nerol or geraniol. The H2 catalyst either reduce the double bond or it will reduce the aldehyde to alcohol. So you can see citral, H2 catalyst, it gave the nerol and geraniol. Now synthesis of ionone from citral, in which an aldol condensation reaction followed by the rearrangement reaction. First step is an nucleophilic addition of carbanion of acetone on carbonyl carbon of citral is the base catalyzation. The aldol condensation product eliminate water through enolate ion. So you can see the reactions. Now reaction of citral. Step 2, the reaction is proceed by acid catalysis, where a double bond open to form carbocation. The rearrangement reactions followed by ring closure. Then the proton is abstracted from the molecules by proton acceptor Y to form ionone. So this is the reaction sequence. Now structure elucidation of citral. Citral form both mono and disulfide by additions of sodium bisulfite to reveal the presence of conjugated aldehyde groups. Its UV spectrum displayed a band at 238 nanometer to confirm this. Now you can see mass spectrometer. You know the molecular mass of citral is 152. Citral show peak at M by Z 29 due to homolytic alpha cleavage. It shows a peak at M by Z 69 due to beta cleavage. It shows a peak at M by Z 124 due to heterolytic alpha cleavage. You can see each peak. Now IR spectrum, CH stages for alkane, CH3 bending 140 and 1375, CH2 bending, and carbon-carbon double bond at 1680 to 1600, and carbon-oxygen double bond 1740 to 1720. So this is the infrared spectrum of citral. Now structural elucidations through NMR, carbon 13 NMR, the chemical shift of carbon 185 to 220 ppm, the chemical shift of C2, C3, C7 and C8 100 to 150 ppm, chemical shift of carbon 4, 9, 10, 8 to 30 ppm, and chemical shift of carbon 5 and carbon 6 15 to 55 ppm. Proton NMR, proton at carbon 1 has chemical shift value 9.4 to 9.8. You can see the aldehyde hydrogen. Number of proton at carbon 2, 3 has chemical shift value 5 to 6 ppm. Number of proton at carbon 5 and 4 has chemical shift value 1.9 ppm. Number of proton at carbon 6, 7, 8 has chemical shift value 1.7 ppm. So uses of citral. Citral is an aroma compound used in perfumery for its citrus effect. Citral is used as a flavor and for fortifying lemon oil. Citral has strong antimicrobial qualities. Citral is used in the synthesis of vitamin A, ionone and methyl ionone, mask the smell of smoke. So friends, these are the reference. If you like this video, then subscribe my channel, and thanks for watching.